right back.
Hey, I got a question before we start. Where is the exam
Where
gonna
is the
be at?
exam going to be at?
Oh,
All right. Sorry about that. I had to step away. The exams, it should be on My Open Math. So all of our assignments are just in My Open Math.
yeah, what is it
Yeah, what is
labeled
it
under? I don't
labeled
see it.
under? I don't see.
Okay. What's the first assignment that you see?
Like for
Like for
chapter
chapter
7.
7?
You don't see anything before that?
Yeah.
Yeah.
Oh, okay. Now I see
Okay.
it.
Now I see.
Okay. Yeah. So older assignments, you should be able to use a late pass to access them, but the exam should be available. So it's like that should be available now. Okay, let me see this as far as announcements go. Uh, Hope everyone's doing well. So I updated the grades based on the assignments from chapters 1, 2, and 3, excluding exam 1. So that's what I did on this past Tuesday. So I usually like to do my grades between Tuesday and Thursday. So as long as you get your assignments into My Open Math, you get them to whatever grade proficiency level you would like, then next time I update the grades, they should get in there, right? So if you've completed something and then I update the grades after that and you still don't see it, then you want to be like, okay, wait a minute, did I get credit for this, right? But if you finish something like on a Friday or Saturday or something like that, just wait until about Wednesday or Thursday, or maybe the following Friday. Usually by then I've updated the grades. So the grades are up to date. I think last time we started on section 7.1. We completed 7.1. So my goal today is to get through sections 7.2 and 7.3, and we were kind of basically working on functions in their graphs. I didn't load the 7.1 whatever we did into my YouTube, but the recording is available in the chat on Teams. Also, when it comes to Teams, so I'm under the impression that the best way to access our class, if you basically like install the app Teams, the Microsoft Teams app, and then, again, I'm still just kind of like organizing and kind of going through files. I still need to update you all's attendance, but I have a record of it. I just need to update the official attendance. And then maybe I'll re-invite everyone to make sure that everybody on my rosters, I re-invite you all to Teams. So that way you're not dependent on me posting the meeting ID. I do acknowledge that it is creating like a new meeting each time. I don't know why it does that. That's Teams. This is like maybe my second time using Teams, and it wasn't this like chaotic the first time I used it. So um, to access, these sessions again, I know I'm preaching to the choir because you all are here, but I'm just saying it just for the sake of saying it. Two ways I know to access. One, you either have to wait for me to post the meeting ID, right? Because it seems to create a new room each time, or simply just go ahead and install the Teams app, and then just I'll try to invite you all to this team, but you should be able to find us in the app, and then you can see all the upcoming meetings on the calendar, and then you can just click on that. That's how I access it, through the app, and then click on the calendar. As usual, if you have questions, feel free to unmute yourself to get my attention or type in the chat. I am monitoring the chat. I'd like to turn my captions on here as well. Okay. Uh, we can suppress this. Okay. And I can't think of anything else. So, you know, this is my last class before the weekend, so I'm always like geeked and excited. I'd be like, let's go. And so I tried to shift gears a little bit where I was like, okay, all those things that I want to do, like updating my YouTube playlist and like loading files and this, that, and the other, and like updating grades. I try to finish that during the week, so that way when I'm done with you guys, if I just don't want to look at this stuff, which oftentimes is the case, like when I leave you guys, I teleport somewhere else. Like I be thinking about trails and running and walking the dog and movies and food and hanging out with people. Like as soon as I leave you guys, that's where my mind goes, right? So, but now again, my goal for today is to finish sections 7.2 and 7.3, so that way we can at least, and we can at least have a copy of these ready to go. And so what we'll do today, um, I'll honor the time. Like once we hit 12:15, release everybody. But if I haven't finished 7.2 and 7.3 by then, I'll do my closing remarks, let you guys go, and then I'll keep recording until I'm done with 7.3. So that way next week we can start on matrices, and I think that's the proper rhythm for these next couple of weeks. Okay, I can't think of anything else, so let's get the party started. So we're continuing chapter 7 on algebra with graphs, functions, and linear systems, and we're working on section 7.2, linear functions and their graphs. A few objectives. One, we like to use intercepts to graph a linear equation. Two, calculate slope. Three, use the slope and y-intercept to graph a line. Four, graph horizontal and vertical lines. Five, interpret slope as a rate of change. And six, use slope and y-intercept to model data. Okay. So here we have graphing using intercepts. So like when you see the word intercepts, right? Where have you seen that word in your everyday life, right? I don't know if anybody's a sports fan, which I am not. I like to play sports, but I don't. I'm more of an active kind of person. I don't like passive that much. So like watching sports kind of like just grinds my gears, and like I don't like that feeling of feeling helpless. But if you know anything about sports, like in football, you have a receiver, a defending receiver, does an interception. What does he do? He crosses the path of the ball, right? The ball was intended for one location, and he crosses its path. He intercepts it. So the way we use intercepts here is similar, right? The word intercept means to like cross, right? Cross the path or whatever. So let's see it in action. So all equations of the form ax plus by equals c are straight lines when graphed as long as a and b are not both 0. And these are called linear equations in two variables. So locating the intercepts, to locate the x-intercept, again, where the graph crosses the x-axis, we set y equal to 0 and solve the equation for x. To load the y-intercept, where the graph crosses the y-axis, we set x equal to 0 and solve the equation for y. Okay. So here's an example. Use intercepts to graph a linear equation. We're asked to graph 3x plus 2y equals 6. Okay. Let me actually start this with, can we access it easily? Okay, that looks decent. I think if I go like this, come on. Yeah, my device. Come on, there we go. There we go. Paper. All right, we want some graph paper and the smallest lines. There we go. Thank you so much. Try to encourage people to be gentle with their devices, because if you start calling it stupid, then the device pretty much goes, your wish is my command, and then it starts acting stupid. So if you're like, just try to be gentle. Not only does it seem like it behaves a little bit better, but then it also helps you to stay calm. Let's see. So we are here. All right, so let's find the intercepts. Now, when I'm finding the intercepts, I like to do the y-intercept first, because I feel like finding the y-intercept oftentimes is easier than finding the x-intercept. Okay, so if we want to find the y-intercept, okay, what we're gonna do is we'll do this color. We're gonna set x equal to 0 and solve. Set x equal to 0. Okay. So if we let x be 0, we're going to have 3 times 0 plus 2 times y equals 6. So then that means 2y equals 6. So then ultimately y equals 3. Okay, so that's our y-intercept. So then for the x-intercept, we set, let me be consistent here. Just going to move this like here. Give myself, oh no. Give myself a little bit of space. Ugh. All right. So for the x-intercept, we set y equal to 0. Okay. So if we set y to 0 and solve, we're going to have 3x plus 2 times 0 equal to 6, okay? Notice that, again, this term went to 0, this term went to 0, okay? So then we get 3x equals 6. Let's divide both sides by 3. X equals 2, okay? So we're saying that our line is going to cross the x-axis at 2, the y-axis at 3. So most of this is focused in quadrant 1. So I'm going to put my origin about here. As a matter of fact, let me just do like this. That's decent. That's decent. Let's go style and fill block. Okay. And then it's a little bit big, but it's okay. Okay. All right. So we'll let the positive x go in this direction. Another thing that I'm practicing is not saying so much, because it's like I keep thinking to myself, hey, stop saying and then when I think it, I just like almost out of spite, I just say I'm like, will you please? Okay, so it crosses the x-axis at 2. So what we'll do, let me see, we'll let this be a 1, we'll let this be 2, and then 3. All right, 1, and then we need to get to a 3 there, so we can go 1, 2, 3, 4. Right? We said this was our 1, 2, 3, 1, 1, 2, 3, 4, 1, 2. Okay. All right. So it crosses the x-axis at 2. So we'll actually I'm going to copy and paste. Copy, paste, style. Let's go blue and blue. Copy. All right, I think we're good. Okay. So the x, let me see, we got a y-intercept was 3. So we'll put a point at 3 if we can get it to stop dancing. Let's go like this. All right. And then I think we had an x-intercept of 2. And then we just connect those with a straight edge. And we idealistically, we should extend the straight edge across the entire graph. Here, when x is 3, what is that? Let me think, give me a moment. That's a 9. We get a negative 3. So a negative 1.5. That's like here. Okay, there we go. And then when x is negative 1, so we add 3, we get a 9. 9 over 2 is 4.5. Okay. So negative 1, 4.5 is here. That looks decent. And then let's, oops. Okay, yeah. Just trying to make it like an arrowhead. It's still a little off. Is it this point? No. Is it that point? No. It's kind of going off the chart a little bit. All right, we'll just go with that. Still looks a little bit weird. Okay. Let's copy, paste. That's fine. All right, that works. Okay. So when we draw a line, we should extend it across the whole Cartesian plane. It's a little bit off, but this will do. Okay. Paper. So yeah, the graph paper kind of takes up a little bit of time, but that's okay. Okay. Ooh, let me turn this off. Hey Siri, turn the heater off. All right. All right, so here we have a type version of what we just experienced. We got our x-intercept, our y-intercept, and we got the same graph. Okay. All right, we're gonna let that be. So the slope of the line through distinct points x1, y1, and x2, y2. So the slope is the rise over the run, which is our change in y over change in x. So if you have a formula sheet, this is a good formula. This is a good item to update that sheet with. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, we see it here. As long as x2 and x1, their difference is not 0. Okay. So find the slope of the line passing through the pair of points. So one of my mentors, oh man, I missed 11. One of my mentors would say every time we use a formula, I write the formula down. Okay. So let's write out the slope formula. Is the rise over run, which is the change in y over the change in x. So that's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, this is our slope. Okay. So I'm a fan, whenever I have ordered pairs, to just go ahead and label them x1, y1, x2, y2. Okay. So then that makes doing our substitution much easier. So now, first thing we do when we go to do our substitutions is insert a blank set of parentheses for each component. So we have our y2 minus y1 over x2 minus x1. Okay. Then we plug in the corresponding components. So our y2 is 4, our y1 is negative 1, our x2 is negative 2, and our x1 is negative 3. So what the blank parentheses do, it helps us to keep track of our signs. Right? Without the parentheses, it's easy to lose track of the signs, and the chances of us making a mistake are drastically increased. All right? Okay. So then if we start to simplify, on top we have a double negative becomes positive. So then that becomes 4 plus 1 is a 5 on top. On bottom we have a double negative. So then we have negative 2 plus 3, which is a 1. So then the slope is going to be 5. Let's go style, fill, none, stroke. What about this thick? That's good. Okay, so we got a slope of 5. And here's a type version of what we just experienced. Find the slope of the line passing through this point. All right, so we're good to go. Okay. So then we have the slope-intercept form of the equation of a line. The slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is this classic y equals mx plus b. All right. So this is the equation of a line with the slope m and a y-intercept of b. To me, this is the easiest way to graph a line because the y-intercept, our b, tells us where to start on the y-axis, and then the slope tells us how to get to the second point. So then once we have 2 points, we just connect them with a straight edge. Okay. So graphing the slope-intercept form using the slope and the y-intercept, first plot the point containing our y-intercept on the y-axis. This is the point 0, comma b, right? Obtain the second point using the slope, write m as a fraction, and use rise over run, starting at that point containing the y-intercept to plot this point. And then use a straight edge to draw a line through the 2 points. Draw arrowheads at the end of the line to show that the line continues indefinitely in both directions, right? You actually saw me do this. Well, we plotted with the intercepts, but it was essentially the similar concept. Again, if we want to identify or graph a line, we just need 2 distinct points and then connect them with a straight edge. So here we're asked to graph the linear function here by using the slope using the slope and the y-intercept. Okay. So let's try to introduce our graph paper again. Maybe we can go a little bit more smooth this time. Go like this. There it is. Paper. This one. Here we go. Now we're cooking with grease. Okay. Move you there. Expand you. Looking good. Okay. Let's click here. Let's see. So our y-intercept is 2, and we have a positive slope. So it looks like we're focused. Oh no! Undo. Oh, what are you doing? What? No, we didn't lose all our work. Let me get rid of this for now. I just want to make sure we still got our work. Okay, so we still got that. Let's get back to where we were. I don't know. It just jumped for some reason. Let's see. Okay, cool. We're still here. Okay. Was it because I clicked up here? Anyway. So we have a y-intercept of 2 and a positive slope. So it looks like we're working in quadrant 1 mostly. So I'm going to put my origin. Actually, I'm going to pull. I can pull most of that out, to be honest. The main thing that I want. Did I pass it already? Here it is. I guess I could take the whole thing. Let's just take all of this. Copy. Let's paste. Paste. Okay, that's fine. All right, so I want my origin. I guess this is pretty good about there. That's fine. Okay. Let me get rid of the stuff I'm not using at the moment. Namely, like this guy can go, that can go, that can go. See if I can get these dots. So there's 1, 2, and actually I just want them to kind of be on call. No. All right. I'll use those a little bit later. Okay. So we had a y-intercept of 2 and then a slope of a positive 2/3, okay? So to graph this, we can just go ahead and move that point. It says our b is 2. So that means we start at 2 on the y-axis. Ugh. Okay. Okay. And then we use the slope to get to the second point, right? So if our slope is a positive 2/3, that means we go up 2 and right 3. So if we go up 2 and right by 3, which is a 1, 2, 3, this is where our second point is going to go. Okay. So now we have 2 distinct points, and we just connected with a straight edge. Let's see. When x is, can we do a negative 3/2? When x is a negative 3/2, that's what, a -1. So the corresponding y is 1. So when we are here, we can go from here. Okay. So kind of like this. Slope is up 2/3. See, 2, 1, 2, 3, a little bit more. Right there. I don't like how far that is. Let's go here. Oh, okay. Let me do one other. Well, yeah. Let me do one other thing. Okay, there we go. That way we got one arrow, and then I'll just do this one manually. Maybe they have a way for me to get both arrows automatically. Let me see. So let me see if I go like do 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 do. Oh, darn. Okay. That was worth a try. Okay. All right. That looks decent. Okay. Let me remove the paper. I mean the graph paper. Okay. All right. So, all right. Let's keep going. I get lost because like I'm low-key an artist. I don't know. I enjoy graphing because it's like drawing, and so it's like fun. So it's a little bit of light in like this logical, cold kind of environment or whatever. Okay, I think we're good there. So this is just a type version of what we just experienced. but they pretty much have the same thing that we have. Graph the linear function this by using the slope. Is that the one? No, that's not the one. Using the slope and the y-intercept. Okay, if we want to use the slope and the y-intercept here, it's probably a good idea to solve for y. Let me first get a copy. I am going to copy this whole thing if I can. Can I just copy this? Copy? Let me see, maybe that might work. Then if I paste, nice, that's exactly what I wanted. Okay. I'm gonna put you there. Let's go paper, let's go some graph paper, shrink this down. Okay. Let me move this over just a little bit. That's decent. And then same kind of deal, right? Let me get rid of the stuff I'm not using, like this and this. Let me move these items. Matter of fact, nope. Let's move you like here. Maybe we can get this other point as well. We'll save those for later, for lates negates. I'm going to move this over to use for later. There we go. Perf. And then let's go ahead and solve for y. Okay. So just like in life, right? You know, we want to know why. Well, I do. It took me a while to realize that everybody doesn't want to know why. Some people just do things just for the sake of doing it, which I totally understand. But here let's solve for y. All right. 2x plus 5y equals 0. Okay. Let's subtract 2x on both sides. Okay, because that's the inverse operation. So then we get 5y equals a negative 2x. Okay. Then divide both sides by 5. Y equals a negative 2 by 5 times, let's clean up that 5. 2 by 5 times x. Okay. Okay, so this one isn't too terribly bad. So notice that we don't have a b, right? So the b in this case is actually 0. Our y-intercept is 0, so I'll go ahead and take one of those points and move it to the origin. Nope. Undo. That's fine. And then we use the slope to get to the second point. Now the slope here is a negative 2 by 5. So that means we go down. Oh, so we need to move this around. Okay. So what I'll do, instead of going by 1, 2, 3, I'll make the x-axis go by 2s. So we'll go 2, 4, 6. This is a negative term. Okay. Let's change the y-axis as well. Let's have that go by 2s as well. Okay. So this is going to go 2, 4, 6, 8. We could rearrange it, but this is fine. 2 and 4. I think this will be okay. And one other thing, let's go paper. I like to use the dots. Come on. Thank you. That's just easier for me to see. Okay. So now if our slope is a negative 2 by 5, let's capture this guy. If we start at our y-intercept, which is the origin in this case, we go down 2 and then right by 5. 2, 4, and 5 is here. That's decent. And then we connect those with a straight edge. Let me see. So for instance, when x is negative 3, that's going to be a positive 6 over 5, so 1 and 1/5. What about when x is negative 2? It's kind of tough to get something clean. Okay. We said 1 and 1/5. So that's like, starts about here. I'm going to do a rough sketch. Let's see. It's 4, 5. That should be 7. When x is 7, negative 14 by 5, so just shy of negative 3. So negative 3 is about, like, right about there. And this one needs to be slightly above 1, like right about there. That's decent. It's passing through the points. So then, let's go paper. Turn off the assist, and that's our graph. Okay. Oh, and then we need to do an arrow in this direction as well to signify continue the pattern indefinitely in both directions. Okay, and then so in slope-intercept form, our b is 0, so it crosses at the origin, down 2 and right 5, and that's the same graph that we got. Okay, what's the time? Okay, cool, let's keep going. So equations of horizontal and vertical lines. The graph of y equals some number, or f of x equals some number, is a horizontal line, and the y-intercept is whatever that number is. All right, so if we have y equals some number, that's just a horizontal line through whatever that number is. If we have x equals some number, that's going to be a vertical line through x, whatever that number is, right? Whatever x is equal to, right? So y equals a number is a horizontal line, x equals a number is a vertical line. So for instance, we're asked to graph y equals -4 in the rectangular coordinate system. Can I paste? Nice, thank you. So put you about there. I'm gonna resize you. Let's turn on this one. Okay. So if we want y equals -4, let's go paper, shrink this down. Come on. We need to renumber this. So let me get rid of these guys. I'll get rid of this. I'll keep these other items. Oh, it's a little bit off. Okay, let's take this whole thing and just align it. Does it behave better? It might behave better. That's honestly decent, to be honest. Okay, we're good. So y equals -4 means it's a horizontal line through y equals -4. So then for our numbers, we'll go by twos. -2, -4, 2, 4, 6, 8. Okay. So then basically a horizontal line through -4. Right here. And then no matter what x value you choose, y is always -4 in this case. Okay, and then I'm just going to move this guy. Okay, and let me just do an arrow on this end. Seems like they should have an option for a double-headed arrow, but I don't know. Okay, that looks decent. Okay, as usual, if anything is not clear, feel free to unmute yourself to get my attention and we can talk about it. Let me reposition this guy. Okay. And then the x-axis, it doesn't really matter in this case. We can go 2, 4, 6, -2. And this is, again, this is the positive x. This is the positive y. Let me go back and add those labels to our graphs. This is the positive x. This is the positive y. Positive x. Positive y. Positive x. Positive y. Okay, I think that was the last one. Okay, we got that one. Oh, we must have just forgot to copy it. I think that's what happened. Okay. Oh, we're going the right way. Never mind. Okay, we just did that one. Again, no matter what x you choose, the corresponding y is always -4. So then that's the graph that we got. Graph x equals -2. Can I paste? That would be nice if I still have it saved. Okay, I can work with this. So if we have x equals 2, that means no matter what y value you choose, x is always +2. So I'm just going to rearrange what I already have.
Hey, Professor.
Yes.
Okay, so not to interrupt, but I need to head out. So is it okay if I head out? 'Cause I need to handle something real quick.
Well, because you asked, no. If you had just left and not interrupted, you would have been fine. Go ahead. I
Yeah,
mean, I really wouldn't know. Like,
I
it's
gotta go to a
yeah. You don't have to
conference.
announce. You don't have to announce that. Like,
All right, I just didn't want to get marked.
yeah. I mean, it's
All right.
it's everything is being logged. So I mean, I think it'll be
All right.
okay. Yeah. I just didn't want to start this wave of people, dipping out. Um, okay, no matter what x you choose, the corresponding y. No matter what y you choose, the corresponding x is always 2. Come on, why are you dancing? So we're gonna go. We'll just put you there and put you like here. All right. So no matter what y you choose, x is always 2 in this case. Come on. Okay. All right. We're gonna let that be. Okay. Oh, again, this is our positive x in this direction and positive y. All right. And so then this is just a type version of what we just experienced, but I feel like it's fairly straightforward. So the graph of y equals a number is a horizontal line, and the y-intercept is b. The graph of x equals number is a vertical line, and the x-intercept is whatever the a is. Okay. So slope as a rate of change. So for our purposes, generally speaking, whenever you see the phrase rate of change, we're really just talking about the slope between 2 points, right? So slope is defined as a ratio of a change in y to a corresponding change in x. Slope can be interpreted as a rate of change in an applied situation. Okay. So the line graphs in what? The line graphs in figure, it seems like there needs to be a the. The line graphs in the figure shows the percentage of American men and women ages 20 to 24 who were married from the 70s through 2010. Find the slope of the line segment representing women and describe what the slope represents. Okay, so the women line looks like it's blue, and basically they're asking us to find the slope. So slope or the rate of change. No, just the slope is what? Y2 minus y1 over x2 minus x1. So our slope in this case would be, let's do 20, what is that? Is that the percentage? 21 minus 65 over 2010 minus 1970. 2010 minus 1970. Okay, what's that difference? We know the numerator is going to be negative. If that were 30, that would be 35 plus 9, 35, 44. And then the denominator. Hey, Google, what's 2010 minus 1970? 30, 40 years?
2010 minus 1970 is 40.
These are both divisible by 4, so we can get 11 over 10. That's the slope. I'll just highlight it like this. So this is the rate of change. So that means that the percentage is decreasing by 11 tenths of a percent every year. All right, so the percentage of women married in this range is decreasing by 11 tenths of a percent every year. So like 1.1% every year. Okay. The slope indicates that for the period from 1970 through 2010, the percentage of married women from 20 to 24 decreased by 1.1% per year. The rate of change is a negative 1.1% per year. Okay. Okay. So let me see. We have a solid 30 minutes. Okay. Let me see. Linear functions are also useful for modeling data that falls on or near a line. Okay, that's where my slides end. So, we're going to kind of let